An anti-CD3 antibody to plisumab in relatives at risk for type 1 diabetes. Introductions. The uses of anti-CD3 monoclonal antibiotics (ADS) as moved from the bench to the basics back experience with the anti-human CD3 and AF03 for treatment or transplant herpes defectus limitations that were largely overcome with the creation of humanistic non-efficacy leading antibiotics teplizumab, otiuzumab, and bilizumab. Predicting studies shows the ability of drugs for reversing hyperglycemia in diabetes, non-obese diabetics, means providing rational clinical trials with diverse agents. Play.
Colobody, a platform for producing multivalent bispecific protein binders. Colobody is Atree's proprietary protein drug discovery platform, which utilizes a short triplex-forming collagen-like peptide to make novel protein binders. Due to the trivalent nature of the molecule, the Colobody molecules can greatly enhance the binding strength toward their targets. The triplex structure of Colobody is thermally stable under physiological conditions. Since polymerization of target binding partners in Colobody greatly increases their availability for binding to a group of specific identical ligands in very close proximity to a target cell, Colobody can increase overall target binding strength, slow dissociation rate, and enhance cross-linking effect, which can prolong modulation of the ligands and facilitate biological potency. Meanwhile, the collagen-like peptide is derived from human serum collagens and has been proven to be non-immunogenic. Colobody can be used to fuse with different target-binding proteins, including antibody fragments, hormones, cytokines, lymphokines, growth factors, lectins, enzymes, and soluble receptor fragments. When the drug is injected into the human body, that present in abundance on cell surface, it can improve target binding strength and cross-linking potency, retain structural and serum stabilities, reduce amount of dosing, and cytotoxicity. An anti-CD3 Colobody, which forms a stable trivalent CD3 binding domain devoid of the Fc fragment of IgG, has been developed. Currently, it is in preclinical development stage. It is designed for the treatment of acute allograft rejection and autoimmune diseases. The efficacy of anti-CD3 Colobody is much better than the marketed interferon beta-1a in the treatment of mouse EAE model for multiple sclerosis. The competitiveness of anti-CD3 Colobody includes: it can be mass-produced and purified. Low-dose treatment showed sufficient therapeutic efficacy. No cytokine release syndrome. Promise results in mouse farm tox studies. Pilot chimpanzee studies showed promise with primary PD and safety. Colobody is especially feasible for making bispecific antibodies by fusion of two different antibody fragments with the collagen scaffold at either ends. A bispecific Colobody, which targets both CD3 and EGFR, was developed to demonstrate the use of such modality. A bispecific Colobody can transiently link a T cell and a tumor cell by simultaneously binding CD3 and a target antigen, EGFR, respectively. This will trigger T cell activation, followed by attacking the cross.
Applications in nursing. As a nursing, the most takes the account of tulisumab in combination with MTX for the treatment of moderate to severe active rheumatoid arthritis in adult patients with inadequate response or interactions to a previous treatment with one or more similars, and it can develop as administrations as monotherapy in case MTX intolerance or when discontinued treatment with MTX is inadequate. Play.
Each T cell has thousands of copies of the same TCR on its surface. An individual T cell generally carries between 10,000 and 30,000 identical copies of a single TCR. There are two types of T cell receptors and both are heterodimers. First one is TCR alpha beta and second one is TCR gamma delta. 95% of the T cells circulating in the body have TCR alpha beta and 5% have TCR gamma delta. T cell either express alpha beta receptor or gamma delta receptor, but never both. Let's have a look on the structure of TCR alpha beta. TCR alpha beta is composed of two polypeptides, an alpha chain which has a molecular weight of 49 kilodaltons and a beta chain which has a molecular weight of 43 kilodaltons. Each chain has two extracellular domains, a transmembrane portion and a cytoplasmic tail. The outermost domain is known as variable domain and represented by capital V. Other domain is known as constant domain and it is represented by capital C. Each of the domain is stabilized by an internal disulfide bond. The variable domains of both alpha and beta chain together form the antigen binding site. After T cell receptors recognize the antigen presented by an MHC molecule, a signal is transmitted from the surface of T cell to the nucleus which leads to T cell activation. But T cell receptor cannot do this alone because the cytoplasmic tail of the T cell receptor is extremely short. It is about 3 amino acid long. So, how this signaling takes place? For this, T cell receptors are associated non-covalently with a complex of proteins. This complex is made up of 4 different proteins, namely gamma, delta, epsilon, and zeta. 2 heterodimers formed by these proteins are known as CD3. First heterodimer is formed by delta and epsilon protein. And second one is formed by gamma and epsilon protein. Besides CD3, two zeta chains, linked together.
Pros and cons. The former two drugs have been tested in subjects with NICs onset type 1 diabetes. They have both shown in recent clinical trials an ability to reduce the loss of insulin production over the first 2 years of the disease. In addition, the NEC fog exogenous insulin to maintain glucose control while the reduces. However, these agents alone do not remove normal glucose control, and futurists approach will likely require combinations of agents with complementary immune or metabolic activity. Great. Mechanisms and actions.
As these stem cells differentiate into common myeloid precursor cells, they start to express the transmembrane protein CD33 on their surface. Cells of the myeloid lineage are known to be involved in the development of acute myeloid leukemia, or AML. Furthermore, these malignant cells are known to express CD33 on their surface. Leukemic cells in AML rapidly proliferate within the bone marrow, interfering with the normal process of hematopoiesis. AML is primarily treated with chemotherapy. However, scientific research strategies involve developing antibodies that specifically bind to CD33. As CD33 is expressed on the surface of AML blasts, it represents an attractive therapeutic target. The interaction between the antibody and the CD33 antigen can trigger antibody-dependent cellular cytotoxicity. Boehringer Ingelheim is currently developing a novel CD33 binding antibody, which has been engineered with the goal to deliver antibody-dependent cellular cytotoxicity. Boehringer Ingelheim's CD33 antibody is designed to recognize and bind to a specific epitope on CD33. BI 836858 intends to cause decelerated internalization, which may lead to a prolonged exposure on the cell surface. It also has a modified Fc region, which intends to enable it to bind with high affinity to the Fc gamma receptor 3A, found on the surface of immune effector cells. Preclinical studies have shown that this engineered antibody exhibits antibody-dependent cellular cytotoxicity. In addition, it has been shown to display antibody-dependent cellular cytotoxicity against AML blasts in vitro.
Swift applied in Ecuador. In Ecuador, tocilizumab is administered on amount to be intravenous infusions, or every 1 or 2 weeks recutaneous injections. Tocilizumab should not be combined with another biological medicines. During administrations of tocilizumab, blood tests will be used to control increases in cholesterol or liver enzymes and reductions in white blood cell evaluations.
a pre-filled syringe. This may be a little bit odd looking, but it is a safety syringe. So as you'll see in a minute, it will really reduce the chance of anybody sticking themselves later with this syringe. So all we need for supplies is our syringe of Actemra, an alcohol wipe. If you don't have an alcohol wipe, that's fine. You can use a bottle of rubbing alcohol and a cotton ball, and a sharps container. So the first thing we'll do is prepare our skin. Now, this is what's called a subcutaneous injection, which really means it's going to enter the body in that layer between skin and muscle. So that area is the subcutaneous area, and it's sometimes filled with a layer of fat. So the best places that we can access to do a self-injection are the abdomen, stay about an inch away from the belly button, and the sides of the thighs, sometimes called the saddlebag area. So the first thing we're going to do is prepare our skin. You're going to wipe in a circular motion with your alcohol wipe or your cotton ball about 30 seconds to get the area clean. You're going to let that dry. You're going to remove the cap of your needle. Into the skin. Once your needle has entered the skin, you want to depress the plunger. Now, you can depress this plunger this way with the same hand, or it may be more comfortable for you to use the
Conclusions. Biological therapy, as is therapeutic strategies of rapid growth and development, allowing the pathological process of the diseases, though especially intervening with safety prophylactics with the recent development of human molecules, and the moments the tendencies inclining to development of human DNA and illustrated that the moments there are more time and research for its clinical uses, including the cardiovascular branch of medicine. Thank you.